Hi everyone, welcome back to my channel. Now in this video, we need to show that the Laplace transformation of sin t by t is tan inverse 1 by x. And by using this, we need to prove integral 0 to infinite sin t by t dt is equal to pi by 2. And the second one is integral 0 to infinity e power minus t sin t by t dt is pi by 4. Okay, so here to solve this particular problem, we will use the formula Laplace transformation of ft by t is integral s to infinite fu du, where fs is Laplace transformation of f of t. Now, since we need to find the Laplace transformation of sin t by t, here we take our ft is equal to sin t. So, what will be Laplace transformation of sin t, which is fs, is we know that the Laplace transformation of sin t is 1 by s squared plus 1. So, Laplace transformation of sin t by t is integral s to infinite 1 by s squared plus 1 ds. Okay. Now, note that this is an improper integral, so we will solve it by using limit definition. So this integral can be written as limit x tends to infinite integral s to x ds by s square plus 1. Now we know that integral ds by s square plus 1 is nothing but tan inverse s. So we can write it as limit x tends to infinite tan inverse s, and the limit will be s to x. So it is nothing but limit x tends to infinite tan inverse x minus tan inverse s. Now we know that limit x tends to infinity tan inverse x is given by pi by 2. So it is the limit will be pi by 2 minus tan inverse s. Now we know that pi by 2 minus tan inverse s is cot inverse s, tan inverse 1 by s. So our first part is proved. Now we have to show this first problem and second problem. Now we need to find what is 0 to infinity sin t by t dt. Now by definition, Laplace transformation of sin t by t is integral 0 to infinite e power minus st sin t by t dt. And this is f of s. Now if we put s equal to 0, so putting s equal to 0, we get f of 0 will be integral 0 to infinite sin t by t dt. Now here we have fs is equal to pi by 2 minus tan inverse s. So here we put s equal to 0, so it will be pi by 2 minus tan inverse 0. And we know that tan inverse 0 is 0, so it is nothing but pi by 2. So we are done with the first one. And again, if we put s equal to 1, then we get f of 1, which is 0 to infinite e power minus t sin t by t dt is pi by 2 minus tan inverse 1. So tan inverse 1 is nothing but pi by 4, so it is pi by 2 minus pi by 4, which is pi by 4. So both first and second problem are proved, hence we are done.